Welcome to Code Spotify. Today we are going to figure out a method to integrate between Kafka, Logstash, Elasticsearch, and Kibana using Docker. Here I'm not going to explain each one of them, so you can understand the basic by referring online videos. So you can find n number of documents in online. Let's get started. So there are certain prerequisites, Docker and Docker Compose. For me, I have used Docker version 20.x and for Docker Compose 1.29.x. So this is how the communication works. If you want to know more about Kafka, press the I button or refer the description. Here I will explain everything in short so that you will have some basic understanding to integrate. So Kafka is a data streaming platform that is used to stream the data from source to destination. It means like from producer to consumer using topics. So the next one is a Logstash. So basically that will create a pipeline. So Kafka cannot communicate to Elasticsearch directly. They need some intermediate. So we are using something called Logstash. So Logstash will create a pipeline between Kafka and Elasticsearch. So that Logstash can read the data from Kafka and forward the data or process the data to Elasticsearch. As you all know, Elasticsearch is a data storing unit that used to store huge amount of data in the form of index. So they will have their own index. Under the index, they will have maintain huge amount of data. Okay. So basically they follow solution library and it is a search engine. So you can able to query the full text search. So next, if you wanted to visualize the data from the Elasticsearch, either you have to use the REST API to get the data in JSON format, or either you have to use a Kibana. Using Kibana, you can directly interact with Elasticsearch to visualize the live data. Let's go to the demo. I'm using a Docker Compose file, which is under the folder Kafka and ELK. ELK indicates Elasticsearch, Logstash, Kibana. Here I'm using a Docker Compose file to maintain multiple Docker containers so that I can run all together in a single command. So the first one is Zookeeper. Okay, in case if you don't know about Zookeeper, please click the I button to understand more about the Kafka and Zookeeper. Okay, so let me tell you in short. So Zookeeper is the one to maintain the Kafka brokers, and that is the one which will forward the messages from producers to consumer based on the Kafka broker availability. So the next one is a Kafka. It will maintain one single broker. You can see there is a broker ID 1. So if you wanted to have a multiple brokers, just copy the set of selected port. Okay. Then I should have some set of environment variable. I'm exposing the port outside like a 29092. Okay. And I'm telling the port with the zookeeper 2181. So the Kafka and the zookeeper will be internally communicated. Okay. So I wanted to tell them where is the zookeeper with the Kafka. Okay, that's why I'm telling the container name. So I mean like I'm giving the zookeeper container name here and I'm giving the respective port number 2181, which is specified here. Okay. So it means once the Kafka is ready, it will look for the zookeeper. Okay. So this is a zookeeper to connect. Okay. Yeah. So the next stage is like health check. This is the most important thing. Okay. This will help you to give the status whether the container is healthy or not. Such. So this is official image. Okay. So these are the basic configuration which is needed, like a Elasticsearch cluster name. You can give any name based upon your needs. Here I will give Kafka cluster. Okay. So yeah, you can give any name. So others are different configurations. Like here I'm going to use as a single node. You can use a multi-node as well. Then these are the ES configurations, securities, all this stuff. And volume. So I already created a name to volume. Okay, if you go here, I have a name. So it means like every Docker will be having a default volume memory. Since I have a named volume, the data on the Elasticsearch will be stored on the volume directory in the Docker. You can keep your own custom directory as well, the manual directory, so that it will store the data in your local file system based on the directory path. Then I'm exposing two ports, 9200, the next one is 9300. Okay, so basically this Elasticsearch is completely depends on Kafka. So it means if the Kafka is ready, then only the Elasticsearch will be loaded, otherwise no point. Okay, then of course the networks will be indicated everywhere. So I want to do communicate between Kafka, Logstash, Elasticsearch, Kibana, etc. If you wanted to make this to communicate each others, everything should be in one single network. So that's why I'm creating a Docker network. If you don't know about Docker network, please refer online. There are a number of documents there. Okay. So once I create a Docker network, so it will generate their own gate type, like gate IP and gateway IP, and everything will be mixed up together in a single network. The next one is a Logstash. So this is the official Docker image, and this is a container name. Okay, so container name will be always unique. You cannot give the same name to other images. Then next, the default configurations I'm given, and this is the most important things. So I'm giving a configuration file which is called logstash-kafka.config. So there is a custom name, you can give your own name, but the matrix is supposed to have this file in the pipeline folder. Okay, so I have this file in a local directory called logstash-kafka.conf. So here I have I have already mentioned the input and output. I'm telling the Logstash, I already told you, right? So if you wanted to process the data and create a pipeline between Kafka to Elasticsearch, Logstash is the one. So here I'm going to tell where is the input and where is output. So Kafka is the input, and I'm telling them container name. You can refer the container name here. And I'm telling them the topic name. Okay, so topic name is code Spotify topic. So this is a topic. Okay, the next one is like where is the output. So output is the Elasticsearch. So I'm going to tell them the Elasticsearch container. So this is the Elasticsearch container. Okay, you can see here this is Elasticsearch container, then the respective port number which is exposed already, and the index name. So code Spotify index. So there is index name here, and I'm going to give only one worker. So if you wanted to increase the worker, that's up to you based on your machine availability and core availability. Okay. Okay, so the next one is Kibana. So Kibana is, as you know, that there is a visualizer. So I already having a dependence, like a dependency with the logs, Elasticsearch. Then I have some default parameters. Then health check. Then I am linking with the Elasticsearch. Okay. So so this is the one which will actually create a link between the Elasticsearch. Basically, it's not mandatory. You can ignore this because we are already creating a network. Since you are creating a network, this link is not needed. Okay. Okay, let's run all together. Let's see how this works. Okay, okay, let me go to the folder. Okay, dot compose version. So this is my current version. Compose up. So before that, I wanted to check what are the containers running. There is no container run. So let me run this command now. It's take a while. Okay, so there are two containers are healthy. One is like Kafka and Elasticsearch. Both are healthy. zookeeper not showing any healthy status because I don't have a healthy status conditions in the Docker compose file. So Kibana and Logstash is not healthy. Okay, now Logstash also healthy. Okay, it is healthy now. So now everything is healthy. Okay, so Logstash, Kibana, Elasticsearch, Kafka, everything is healthy. Okay, let's verify one by one. Okay, so this is my GitHub repository. So I have the commands to verify. Let me check the topics first. So this is a command to verify the topic. Let me clear this out. Okay, so there are two topics, consumer underscore offset, and other one is a code Spotify fun topic. So consumer underscore offset is helpful for the zookeeper that is used to maintain all the offsets here. So that is totally controlled by zookeeper. So that is always created by default, and code Spotify hyphen topic, which I already mentioned in the logstash conf file. You will have seen here. Okay, since I already mentioned, so by default it will be created. Oh, not by default, it's created by Logstash. Okay, so let's monitor this. So if you so how I can verify it's working, right? So I'm going to produce a message and I will be consuming from other end. Okay, okay. Let's go to the command. Okay, here I have a consumer. Before that, let me have a producer. You can ask me why you are using this command. You can see here docker ps-a. So basically this is a container name, Kafka-cntr. Okay, so I'm going to use a exe command to enter inside the container. Okay, so for example, I'll show you here. Dash. See, I'm inside the container now. Okay, so it's not my local directory, it's inside the container. Okay, so instead of entering inside the container and running the command one by one, I'm running everything directly, that's all. Okay, so here I'm going to run this command now to produce the topic. Okay, okay. So in the meantime, I have to run the consumer command. Oh, sorry. Is this a producer or consumer command? Okay, producer command. Let me run the command for consumer. Okay, so I already have the topic name. I given the topic name. So from the beginning. Okay, so if you wanted to bring everything from the beginning, for example, you have stopped the I mean you have processed some messages before, but unfortunately you have stopped the respective instance. Then again, when you are starting, you wanted to bring all the previous messages back in the sense you have to pass this command called from beginning. Okay, okay. Let me pass the message. Welcome to core Spotify. See, the message was triggered immediately. So it means like the Kafka is working. Okay. So now you will not be understanding how come the Kafka is working immediately. So now I wanted to explain how the network works. So there is something called Docker network. So this is my network name. I have given this network in the YAML file. Okay. So this is a network name. You can see there is a prefix called Kafka-ELK. This is nothing but this folder name. Okay, so they will, if I am not given the project name manually, by default they will take the root folder name. Okay, so let's inspect this. Come on, you see, you can find all the Docker images within one gateway. See, this is a gateway. Within the gateway, there are few Docker containers running. That is Elasticsearch hyphen container and Logstash hyphen container, Zookeeper, Kafka, Kibana. So everything's running inside the one single gateway. So it means like they have their own private network. You refer the IP here. Everything start with 172.22.0.4.5.2.3.6. These are the host names. So that's sorry, these are the host ID. So you can see everything in a one single network, right? Okay. So if you wanted to ping, you can ping that. Again, let me first. Okay. So here, let me show one of them. The Elasticsearch. The port number here. The port number exposed is sorry. This is a Kafka. Here the port number exposed is 9200. Okay. And what is IP for the Elasticsearch? So this is IP, right? You can see here the Elasticsearch container. And copy this and 9200. I'm not sure that I have telnet. I have telnet. You can see I can able to communicate. It means it's connected. Okay. So it means the respective IP and the port is connected now. It's working fine. So this is how you have to test whether the Elasticsearch or any of the container which is already created inside the network is working fine. This is how you have to do the testing. Okay. So now I have verified the Kafka is working, right? The next one is how to make this working in the Elasticsearch. So I cannot visualize in the Logstash, but I have a log here. So basically I have a log for Logstash. I don't have visualizer for the Logstash. I will show the log here. So put the new tab. Okay, Docker logs. Okay, so this was the last message which was inserted. Okay, now I'm going to show the message in the Elasticsearch. So Elasticsearch was 9200. You can see here. Yes, I can. 9200. Okay, localhost colon 9200. Okay, so this is a cluster name. You would have seen this cluster name I have given in the YAML file. You can see here, this is the cluster name I have given. Let's go inside. Okay, so this is the index. So this index has been provided in the logstash conf file. You can see the output will be in the index. Okay, so now let me trigger the REST API. Okay, I have the index already. Let me trigger the index. You can see the message is welcome to Code Spotify. Okay, so let me show you one more message. Wow. Kafka message is working. Okay, let's check the producer. See the producer. Oh, sorry, consumer got the message. Go to Elasticsearch. See the message. Okay, so we can find everything in the REST API response. Now I want to visualize this in the Kibana. Okay, to the Docker list. The Kibana port number is 5601 and the Kibana name is Kibana-CNDR. Okay, so since I expose the port outside, I can access directly from localhost. Localhost. Okay. Create an index. Okay, I have index code Spotify index. Do this. Go here. Timestamp. Create an index pattern here. Okay. Go here and discover. Okay. You can see the message here. This is the last message. Okay, so let me trigger one more message. Kibana is working perfectly. Okay, consumer got the message, and let's check the uh, Logstash logs as well. Okay, here you can see Logstash log. So yeah, the message was pinged. This is the last message. Now go to REST API, hit that, it's working. See, I got another message, Kibana is working. Let's come to Kibana. See, wow, Kafka message is working. So I got the message now. So if you wanted to get the message, you don't need to load this refresh this page, just refresh this button. You'll get the latest data here. Okay. If you want to have more than 15 minutes, then you have to adjust the data. Okay. You can see I updated. I got all the messages now. Okay. So Kibana is working perfectly. So wow, Kafka message, welcome to Spotify. So here in the REST API also you can see I have 3 messages. I received all the 3 messages here. So likewise, now you can see each and everything is communicating each other. It means like from Kafka producer. Okay, this is a producer. From the producer, message is forwarding to the consumer. From consumer, the message is forwarding to the Kibana. You can see here from extremely sorry. So Logstash, from Logstash, the message is forwarding to Elasticsearch. Okay, you can verify that by REST API, and from the Elasticsearch we are visualizing the data in the Kibana. Thank you. That's all for today.